Good evening to everyone, and thank you all for coming tonight. Just a few first of all, introduce myself. I'm Krishna. I'm with Bram. We're the presidents of SciSoc. You may notice that the meeting is being recorded, and it will be done so in the manner that was stated on the form which you used to sign up. We ask that you can, if you can, keep your cameras off and your mics muted while Professor Evans is speaking. There will be opportunity to ask questions afterwards, at which point you can turn on your cameras and your mics. So to introduce tonight's speaker, we are very happy to have Professor Steve Evans with us tonight. He is a director of research in the Center for Industrial Sustainability at Cambridge. He spent 15 years in industry, has 30 years of academic experience, which, as some of you may have heard, includes working collaboratively around the globe. He's been specialist advisor to the House of Lords and has founded many a clean tech startup. So we're really, really happy to have such a wealth of both academic and practical knowledge with us this evening. So Professor Evans, thank you very much for being here.
Thank you. And now I'm going to turn on the presentation. I must warn you that all those experiences were enormous failures. So just because you have a lot of experience doesn't mean that they were good experiences. So let me start, and thank you for sharing your time with me this evening. I hope that I'll give you some information that will make you look at the world differently. That's my aim, actually, because I study a part of the world that many of us just ignore. We don't see it very often. We don't have to study it, but it is all around us. The industrial system makes everything. It makes the computers that we're looking at the moment. It makes our phones, our desks, our clothes. It makes the bricks that go into the buildings. But many of us don't spend much time living inside that system. And we sort of presume it has certain behaviors. Well, some of us spend our time living in that system and studying that system, trying to understand its behavior. And my particular interest in studying the industrial system is trying to answer the question, how could the industrial system change to be in harmony with the natural system, to be sustainable? And I'm going to put some numbers to that, because both industry and system and sustainable are contestable concepts. So what do I mean? If we want a sustainable industry, simplistically, we would like industry to deliver 3 times more output in 2050 than it does today. That seems like a strange request, but it's an important request, because we want to lift people out of poverty. And one of the ways we do that is give them access to safer food and clothes and other gifts of the industrial system. We want all of the factories in the world to be non-polluting, in other words, to be a clean neighbor. We want them to emit 100% less greenhouse gases than they do today, and halve their resource use while meeting the other conditions that I mentioned here. So when I talk to people about the industrial system, and I'm going to make a reference to politicians here, politicians really understand cars and buildings. So when you talk about the sustainability of transport, of moving things around, when you talk about the heating and cooling and the energy it takes to make the glass to go in that building, politicians get it. But that's because they spend time in cars and buildings. They don't spend much time in factories. And so largely, the third part of the system that delivers the majority of greenhouse gas impacts to the world is ignored by politicians because it's misunderstood. And typically about 30% of greenhouse gases comes from moving things around, about 30% of it comes from buildings, and about 30% of it comes from the industrial system. The rest comes from direct emissions in farming. And we'd like the industrial system to be 3 times bigger to give us access to those lovely products, but it needs to be much smaller in terms of the footprint that it places on the world. So let's ask some questions. How do you deliver that? That's my research. So a bit of a Cambridge picture. What I deal with is the shadow, not the bicycle, not the product of the manufactured system, but the shadow that every product carries with it. And by the time we finish today, you might have a better understanding of the shadow and how that shadow interacts with the natural world. Now, I am a researcher, and you might expect me to look a little bit like the gentleman on the left, in a lab trying to invent new technologies that will allow us to generate those products of the future with less of a footprint. In fact, I'm more like the researcher on the right, because we ask questions like, how efficient can we be with existing technology? We're not trying to invent the technologies of the future. There are many laboratories globally, including in Cambridge, who are doing a fantastic job at inventing those technologies. One of my arguments today is we already have enough technology, or we're very close to having enough technology. So if technology isn't the problem, what is the problem? And I want to try and get to that. Now, as a researcher, I study the interaction between technology and people and money. And it's their interaction that generates the behavior of the industrial system. So I've just pulled out an example. I used to work for a car company. We were one of the better ones. It cost us $400 million to launch a new car before we sold the first car. That car might have been sold for $400 profit. Think about those numbers there for a minute, and that helps you understand a lot of the behavior about why cars are designed the way they're designed, about why cars are marketed the way they're marketed, about why their fuel efficiency is at the level that it currently is. So understanding the interactions between these factors is really important. If you run a factory that was planning to make 112,000 cars a year, that would have made you very happy. If you only make 100,000 cars a year, think about that. Making 100,000 cars a year is a really busy activity. Bing, 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 coming off the production line. It's like burning money. You design the factory to be absolutely optimized at 112,000 and 100,000, you may as well not have built the factory to begin with. And that sensitivity, it massively affects how the car system works. So we're interested in the interaction between systems like that. And I want to start by making you angry, outraged. You may know the answer to some of these questions. How efficient are we today? Well, about 50% of edible food doesn't get eaten by anyone. About 73% of UK trucks are empty. And about 90% of processed material never reaches the customer. So actually, we're not that efficient. So how come a system that's supposed to be incredibly efficient, when you study it as a system, becomes less efficient? Again, a question that I'm going to try and answer today. And this is my frightening statistic of the day. If you dig up 100 kilograms of material out of the ground, either through mineral extraction, mining, or through growing product, 6 weeks after the customer has bought it, only 1 kilogram of that 100 kilograms still continues to be used by that customer. 99% of it has gone into waste. That's not a very effective or efficient system, especially when it costs the planet to deliver this material to us. So let's study how that works. And my talk is going to be split up into innovation that works across the 4 elements of the system. Here we're going to talk really boringly. I'm going to talk for ages about just being efficient. We're going to talk about value innovation, technology, and systems. So let's talk about being efficient. For most of us, we believe that factories are the place in the world where you go to efficiency. You don't expect people to be efficient at home. You might not even expect them to be efficient in a hotel where service is optimal and you want to have lots of people hanging around waiting for your orders. But we assume factories are going to be incredibly efficient? Well, let me give you some information. I'm going to talk firstly about energy efficiency rather than labor efficiency. So what is the most energy efficient car factory in Europe? That's the sort of question we might ask. You don't need to understand the picture in the middle is deliberately small enough not to make you go and stare closely at your screen. But I can tell you that the factory that's about 2 hours drive from here, the Toyota factory in Derby, is the most energy efficient car factory in Europe. And what that diagram does describe is that for the last 14 years, they have reduced their energy to make each car by 8% every year for 14 years. That means a 77% reduction. They can now make 4 cars for every car that they used to make 14 years ago. The same amount of energy now reaches 4 cars. That's amazing. And what's even more amazing is they did it without spending very much money. Hardly any, actually, single, hundreds of dollars in many cases to make this happen. So how come the world's most admired factory, this is Toyota. If you're in my world of manufacturing, everybody wants to visit Toyota factories. They're the best factories in the world. So how can the best factory in the world become 4 times better at energy efficiency? Well, one of the things they did is called no production equals no energy use. So when you're not making cars at the lunch break, in between shifts, at the coffee break, you just turn off the machines and they're not used. And you can see some examples of that there. And that moved them from the red line of energy to the blue line of energy. And that saved them considerable amounts of money. Now, I'd like to ask the room, are you smart enough to come up with the concept, when we're not making cars, we shouldn't be using energy? Because that's the level of intellectual novelty that is required to deliver a sustainable industrial system. In other words, it isn't actually conceptually clever. In practice, it's hard to implement it in a safe and efficient manner. So detail is really important, but the brain power required to come up with these ideas is not massive. So we also ask ourselves questions leading on from that. Well, what if every factory in the UK could equal the best factory in its own sector? So what if the best bread factory was copied by all of the other bread factories? What if every car factory in Britain was as good as that Toyota factory? And the numbers are quite revealing. On average, those factories would be 24% more profitable. They would emit 9% less greenhouse gases. They'd also have more jobs. And one of the reasons they'd have more jobs is that we also measure material efficiency. And if you want to be efficient in the use of materials, you tend to reuse and recycle more of the materials. And recycling and reuse of materials tends to be job intensive. And that's why jobs go up at the same time as profit goes up and pollution goes down. So why don't we want this? Why aren't we making this the norm? Part of my research answers that question. Why are companies not getting on this journey when they know that this data is possible? So for those of you who read the email, I was asked to pose a challenge. And I did write in the email this question: how much water does it take to make a single pair of denim jeans? And I offered 6 options. We're not going to do a poll now because we don't have the technology to do that set up yet. But I'm going to say the first 3 numbers, 11,000, a very precise 9,982, and 3,500 are all calculations by the denim industry for how much water it takes to make and wash at home a pair of denim jeans. That's a lot of water, just one pair. In extreme, 11,000 liters. I promise you that's a lot of water. So we were working with a jeans factory in Vietnam, and we were working in a factory that took 800 liters of water to make one pair of jeans. And of course, they make many, many, many pairs of jeans in one day. At that time, the world's best target was 435 liters of water to make one pair of jeans. So we wanted to reduce the water. What target did we set? Should we set 600, halfway to the best in the world? Should we set 434 so that we could become the best in the world by 1 liter? In fact, we didn't set a target. We just said, we're going to improve every year. Let's see where it takes us. Well, it took us down to 1 liter. We were completely shocked by this. We went from 800 liters to 1 liter of water to make a pair of jeans. I don't know what that is in percentage terms. It's pretty impressive. If every jeans factory in the world took the same route, they wouldn't be factories that would be derided for the amount of water they're extracting from the local river or for the amount of blue water they're sending back into the river. Because at 1 liter, you don't have to do that. You're recycling the water inside your own system. So absolutely radical change is utterly possible within the system that we already have, within and using the sets of technologies that we already have today. So maybe my research is more about psychology and why people don't do what seems to be common sense. Now, when I have this conversation in front of some industries, especially what we call the energy intensive industries, people who make steel, aluminium, cement in this case, they say, hey, Steve, we've been doing energy efficiency for decades. Your research findings probably won't work with us. And I sent a PhD student who'd never been in a cement factory before into a cement factory looking for certain sets of data. And if I told you that the y-axis here is kilograms of CO2 per ton of clinker. Clinker is the halfway product where you're going from limestone to cement. So each blue dot represents a day of production. On the left-hand side, you can see that there's a day where the factory emitted 430 kilograms of CO2 to make 1 ton of clinker. And at the other extreme end, it's about 190 kilograms. So this is a factory. Nothing varies. But somehow you can go from 190 kilos of CO2 to 430 kilograms of CO2 to make the same product in the same factory using the same procedures. This is enormous. And what we've suggested, strangely enough, is that this factory should try to have more good days. I know we do appear to be geniuses sometimes. So if you have more good days, if your 90th percentile day actually in the future becomes your 50th percentile day, you would emit 19.7% less greenhouse gases for the same cost and the same profit. This is the second most climate change intensive industry in the world. 20% reduction in greenhouse gases at no cost is feasible. They're not doing it. Why don't organizations do this? And I think there is some explanation for this. I'm a manufacturing engineer. I have been trained to make people, labor, and capital, machines, as efficient as possible in factories. I can go into a factory and from 100 meters away, I can see that something's not being done efficiently in terms of labor and machinery. But actually, labor costs are the blue line in British manufacturing, and the red line is the purchase of goods, materials, services, energy, water. It's 5 times higher than the blue line, but all of my training is to keep the blue line down and the red line is running away. So it's really interesting that I have a tool which 100 years ago was really useful and important because the blue line was higher than the red line, but we're still applying it only to the blue line. So maybe that's one of the possible root causes of why energy and water efficiency isn't taken seriously enough. Wow. How much can you talk about efficiency without sending people to sleep? I can't test because I can't see your pictures. So do wake up because the rest of this might get interesting. But I'm not actually apologizing, am I? I'm making the point that if only we could see waste sensibly, if only we could learn how to be efficient, we could get on an 8% per annum pathway for reducing industrial energy and pollution, which is about 30% of global greenhouse gases. So if we did that, that would be delivering somewhere around 3% of everything we need. 3% per annum greenhouse gas reduction right now. We need to be on a pathway of about 5%. So we can deliver half of that pathway profitably today. So I'm quite keen on helping the world learn how to be more efficient. Eventually, it doesn't run to zero. Doesn't matter how hard you squeeze at 8% per annum, you never reach zero. And maybe it runs out. So then the research moves, and we run, and I have research groups which also study innovation in these other corners of this model. So now I'm going to explore value innovation. What does value innovation mean? Every time you go to the shop, you buy something and you exchange that product for money. That's the most common form of value exchange. But it's not the only way. You probably don't own your mobile phone. You probably didn't pay the £800 it took. You're paying for it through a monthly deal, for example. So there's much more innovation about how we are potentially exchanging value with those who have the knowledge to produce goods and sell them to us. And now I want to talk about a very particular problem, fast fashion. I'm sure nobody in this group suffers from the problem of being called a fast fashionista. That's what they're called. A fast fashionista in the UK spends between £50 and £75 every week. They typically buy one marquee item and a variety of accessories. That marquee item has a modal use of one. This is interesting. You'd imagine all these people are rather wealthy, but in fact, the average credit card debt of a fast fashionista is about £3,500. So even the people who do this can't afford to do it. That's their average debt, right? There are some people in much worse situations. And by the way, their homes are nowhere near as tidy as the picture on the left. So what might we do about that? And if you talk to politicians, or maybe even parents or wives or husbands of these people, they might conclude that these people need retraining or some sort of frontal lobotomy. I would like to draw a different conclusion. What if each of these people paid access to own a card with the number 20 on it that I've shown on the right-hand side? So their wardrobe is allowed to have 20 items in it. But the really cool thing about this card is they can take any number of those items unwashed back to the shop and swap it for anything in the shop at any time. Think about that for a minute. You only have a wardrobe of 20 items at home, but you have a wardrobe of 20,000 items in the store or 2,000 items in the store. So you have access to two different wardrobes. I'm going to encourage you to believe that that delivers the same degree of fun that fast fashion delivers those people who are paying £50 plus per week. I'm also going to encourage you to think, I want to ask some hard questions here. What does this cost? How expensive is this very lovely service that you're offering? And what does it cost the planet? And what does it cost the company? So we've done this work with one of the top 3 major retailers of clothing in the UK, and we've done the detailed modeling of how such a system would work. When I talk about detailed modeling, we're talking about what percentage of buttons would be lost and what percentage of garments couldn't be put back on the shelf when they came back from the customer. What percentage would have stains that would be accessible to be cleaned and not. And we ran about 1,709 real life experiments, if I remember the number correctly, with real life customers to gather the data to build this model. What did we discover? The company can be 200% more profitable, so trebling profit. At the same time, the customer accesses this for £100 a month. It's about 60% cheaper than what they're already spending today. And you go, well, this is all a bit crazy. That sounds nice from the customer viewpoint and from the retailer viewpoint. What about the planet? Well, because you are keeping each fiber, each molecule in the value system for longer, going round and round and round and round, you actually have to grow 50% less cotton. So you're saving that land use and you're saving the greenhouse gas emissions that come from growing the cotton and from processing that cotton into garments. You actually save a little bit more, but you then need some of that greenhouse gases in order to clean and wash and reuse the fibers once they get into the shop system. So I want to encourage you to think, this is current technology, right? This is not even being efficient, but this is dramatically changing the relationship that we have with our products. And I want to keep exploring that and keep asking the question, well, what would that deliver? So we help organizations around the world. They use our insights, which we offer as tools. They use our insights through those tools to help explore business models like this. One organization that we work with is called Elvis and Cressy. For those of you who are into handbags, I would encourage you to do a very quick search for Elvis and Cressy while I'm talking. Elvis and Cressy are a couple, they're married, and they're sort of mad environmentalists. They live in London and they live very close to a fire station, and they used to see the fire brigade leaving outside fire hoses after they were finished with. So it takes about 20 to 25 years for a fire hose to become useless, and then they're left out. And they started, with their permission, picking them up and taking them home and trying to make products out of them. They started by trying to make roof tiles for things like garden sheds, and found that the waterproofing, which is what had stopped working after 25 years, was a necessary component of roof tiles. So it wasn't actually a brilliant idea. And then one day, Elvis's belt broke and he made himself a belt. You will see a more modern version of that belt on the picture of Cameron Diaz there. And all of a sudden, they went from people making potentially quite bad roof tiles to making quite nice belts. And then they started making handbags. So how much, for those of you who are looking online, how much is a handbag made from waste? It's about £200 or more, depending on which one you want. So we can make £200 products from waste that's lying around in our street. This is not a bad business to be in. And I would encourage all of you in this room right now to learn how to open your eyes and look around for waste and do what we call treasure hunting. That waste could be turned into treasure. It's not treasure yet. We still have to do some work to it. But to turn it into a £200 item from something that is zero material cost is quite a fantastic achievement. Well, you might be expecting me to talk quite a lot about technology. How's technology going to help us solve this problem? And actually, I'm not going to do it. I'm sorry. There are many technologies out there. If I choose one, I would appear to be an advocate for that particular technology being one of the technologies that would make a breakthrough in a particular area. There are many, many fantastic technologies out there that are helping the world of industry, factories, make products in a more sensible, sustainable way. But I'm not going to offer, because I could spend an hour just going, here's a slide of another technology, here's a slide of another one, here's a slide of another one. I'm rather more interested in the problem of system innovation. So if you imagine the world has somehow been become clever enough to learn how to be efficient, to make lots of savings in the factories of the world, and then learned how to deliver value in different ways through the retail system, so that actually we make less in the factory but deliver more value to end customers. Let's imagine the world has already learned those things and is continually rolling out, absorbing, bringing to scale a variety of technologies. Even if you do all of those things, we will not achieve the final changes needed to bring the industrial system into a state of sustainability. We will be traveling less lightly, treading less lightly, less heavily, of course, treading less heavily on the planet. We might even be 80% less burdensome, but we won't achieve zero. We won't be sustainable. We are still extracting resources, and eventually, over a period of time that will be even longer, we will delay the inevitable breaking of the natural system. So we need some type of systemic innovation. And I wanted to give 2 or 3 examples of system innovation. So we also study this. How does the industrial system change? And one of the things that's very difficult here, if you imagine a complex system of many, many, many factories that it takes just to make this phone product, or even just to make a cup of coffee, you cannot make the change just by working with one factory or with one company. It's at the system level. So we study systems thinking. And the interesting thing about systems thinking is it's obviously a good thing. But what we tend to do is we tend to draw upon examples where somehow people have accidented upon systems thinking. And actually our research goes to find what we see as better examples of systems thinking, and then looks to their history to try to understand in a systemic way what are the skills and tools of good systems thinkers. So we're trying to actually understand, parse, what does systems thinking mean, rather than have it as a label that says, wouldn't it be good? Wouldn't it be great if we were all fantastic systems thinkers? Unfortunately, it's not very common. The good news is that it can be learned. And without going through some of these boring details in here, there are very specific skills and techniques used by the best systems thinkers that we can learn from. So let me give you a couple of examples, because this all sounds very esoteric, and I want to talk about a very particular system. So I referred earlier to the $400 million that it takes before you sell your very first car. The car industry is incredibly mature. There is almost no product in the world, I would suggest, that is as value for money as a car. You can buy a car for the price of 5 smartphones. I mean, really? That's enormous value. Not only does it get you from A to B, it gets you from A to B safely. You don't feel that you're risking your life every time you get in a car. It gets you there quietly. But if you look at the picture that I've offered here, the difference between a 1948 and a VW Beetle 60 years later, one is faster, one is quieter, safer. It has a flower in a vase. It has a radio. It's much more comfortable to drive in, but it has the same fuel efficiency. And that's a consequence of the way that the industrial system around cars has grown. Henry Ford attempted to own every dealership and the petrol stations. Now, it could be because he was a bit of a megalomaniac, but it's also insightful because if he had succeeded in doing that, he might have found a way to have changed the industry model because he would own enough of the variables to do that. The problem with the current industry is that once you've decided to buy the car and you've given them your money, the fact that you spend lots of money on fuel becomes your problem. It isn't the company's problem who designed the car. So they only have to get the number, 38 miles per gallon, to reach a point which is acceptable to you. It doesn't make them more profitable for that number to become 39 or 40 or 58. So let's imagine that we somehow had the ability to buy a 94 mile per gallon car. That's 3 liters per 100 kilometers in global measurement. What was the first year you could buy such a car? And I don't mean an exaggerated promise on an electric vehicle. Well, the Audi A2 3L, seen here, very standard car, but with a very particular version of it, was made available to the British public in 2003. 94 mpg. It is 2020. You still cannot buy a car that is anywhere near this performance. So what happened? And what happened was that the car industry at the time, and in particular Volkswagen Audi Group, were very worried about the way legislation was heading in Brussels. And they thought that it would be very good to have fuel-efficient cars in their fleet available to sell to the customers. So in the late 1990s, they set out designing this car, and they designed a 94 mile per gallon car that works just like, when you're in this car, it's just totally normal. It's a petrol engine car. It's not electric. It doesn't do any of that fancy stuff. It's just a very efficient petrol engined car. When they launched it in 2003, the politicians changed the legislation in a different direction. So they decided to implement fuel fleet average targets for companies. So that meant that if you were selling very efficient cars, in 10 years' time, your target that you would be set would be N% less than today. So selling fuel efficient cars today was a really bad idea. What you wanted to do was have gas guzzlers today so that your future target was easier to hit. So they stopped selling the car. I mean, you should be outraged, genuinely outraged, that this is the very poor interaction between politics and technology and business that occurs if you don't think systemically. But if you do think systemically, you could do something dramatically different. So this is a car picture. I'm happy to say it's in the middle of Wales, that this car is manufactured. The company's called Riversimple. What is the most efficient car that we can profitably make today? This car is a 240 mile per gallon equivalent car. It uses hydrogen to generate electricity, which runs motors in all 4 wheels. It doesn't deliver the $400 profit that I mentioned earlier. It's 10 times more profitable per car than that at the same cost to the customer. So how does it do that? How can it be so clever? And the key point about this car is you can't buy it. You own it in the same way you own a mobile phone. So you pay to have your own car per month. You pay for it to sit outside your house per month, and every time you drive it, you pay per mile or kilometer driven. When you go to refill it with hydrogen, you don't pay for that hydrogen. You pay per mile. So every time you go to the filling station, it's free. Not only is it free, every time you go to get your car repaired, you go back to this company and they repair it for free. They maintain it for free. They give you the annual maintenance for free. It's all in the monthly and mile cost. And because of that, the company is directly incentivized to make it as reliable as possible. as easy to repair as possible, and as low fuel as possible, because the less fuel they sell you, the more money they make. So because of the way that they've set up the deal with you, they are now able to sell you a car that is 240 miles to the gallon and 10 times more profitable than a Volkswagen Beetle at the same cost to you. I think that's quite a win. I want to give you a very different example now. About an hour's drive from where I'm sitting in Cambridge is the sugar factory at Wissington. Now, if you look at the blue square in the middle at the bottom, that's the sugar coming out of the factory. And if you follow the arrows backwards, you will eventually reach a blue square directly above it, where the sugar beet is made on the farmer's fields. The sugar beet comes into the factory, various things are done to it, it eventually becomes sugar. But while those various things are done to it, one of the things is that you take off the skin of the sugar beet. And like everyone else, they press and dry and pelletize that, and they give it or sell it back to farmers as animal feed. Pretty much every sugar factory in the world that uses beet does the same thing. But what they've done is take this to an extreme. They've realized that there are other wastes. If you have soil coming off, we can sell that back to garden centers. And when they go more closely into the production process, there are some very specific wastes that are skimmed off the water-based sugar. You take the surface off, and inside there, you will find small quantities of really interesting molecules like betaine, which is what we call a nutraceutical and is valued at about $6,000 per kilo. What did we do previously with this? We threw it back on the farm. So let me think about that for a minute. We are throwing $6,000 per kilo molecules onto the farmland. It doesn't help the farmland. So what this company has done is find a way to extract every piece of value from the waste. And I believe that last year, this is an enormous factory. If you go and visit, it's enormous. It's a mile long. I believe last year there were 3 truckloads of waste left this factory in a year. In a normal day, 120 truckloads arrive. In a year, 3 truckloads leave with waste. Everything else has been valorized and turned into money, and it makes this particular location the second cheapest place in the world to make sugar. So this is really profitable, and they have people with PhDs and masters. So this is a high wage, high knowledge industry that's more profitable because it's using that knowledge. Again, the most surprising thing is it's not copied everywhere. If I go to the next sugar factory another 40 miles away, they don't copy this model, which is really frustrating. Should be frustrating for them, but somehow they don't think so. So on that point, I'm going to try and refrain from talking too much about history and politics, but I think that's inevitably where we end up when we start asking questions about what the future holds. Because what I've talked about is, why is it that the Industrial Revolution has generated a knowledge set that allows us to be incredibly good at labor efficiency and equipment efficiency, but not very good at water efficiency, and not very good at energy efficiency, and not very good at pollution efficiency. We use the same knowledge, we just haven't applied it in the right space. We might also talk about politics in the questions, because we can see that the way in which we want to solve challenges like fast fashion, we end up with politically simplistic solutions rather than detailed understanding of the system and looking for those solutions which can flip the behavior of the system without necessarily confronting and having a front-on attack. And I'd sometimes use the metaphor, rather than wrestling the problem to the ground, we want to use a judo approach. We want it to use its strengths, and we will turn that into a weakness and flip it to the ground. So welcome to a conversation, an after speech conversation about judo and how we can use that to solve really important problems of our time. Thank you.
Oh, thank you very much, Professor, for that incredible talk. Would have been nice to hear about the judo, but another time perhaps. If anyone has any questions, please do feel free to unmute yourselves and turn your camera back on, and you can ask them directly. Or if you want to put them in the chat, I can read them out for you.
Hey, can I have a question? Can you hear me?
Yes, we can.
Right. So one of the questions that popped out to me is, you talked about the sugar factory, you talked about the fact that you can walk into a factory and see all these inefficient processes. But the thing that I see as problematic is that's you, and there is only one you who spends that much time on it. And the farm has masters and PhD students working on it. Isn't this fundamentally limited by basically the intelligence of the people involved? Because if you have a smart electrician, he will automate and make things quicker and more efficient if you have a smart plumber. But that's not the case for everyone. And isn't all these processes and all this inefficiency, doesn't it come from the human side? Yeah.
So if I wonder how much you have heard about the way that the Japanese production system has overtaken the world of making things. And that's a system that has been learned. So 40 years ago, nobody operated the Japanese production system outside of Japan. Now everybody operates it. So it is possible to learn these skills in a scaled way, to be able to teach thousands and hundreds of thousands of people to go out and do it in the many factories of the world. And remember, they should be directly incentivized to deliver this education to their people because it pays back, right? We're not asking them to do a donation to the world, to society. They're doing it for self-interest. So a lot of our research is about scale. I refer to my ability to go into a factory and do that. What we study is the many people who do it and look for patterns across those so that those basic patterns can be easily learned by other people. You do point to a really important problem.
Thank you.
I can answer Eleanor's question quite directly. When you make a calculation and you're comparing fuel efficiency or carbon efficiency between different forms of energy vectors in cars. So we all know that if you do an electric car, it's really easy to make it look good if you come to the conclusion that the electric car is taking its energy from a windmill, right? And that's a bit of a way of cheating. And we make people who make those calculations for electric cars, we make them do it on what we call grid average carbon intensity so that we can make sensible comparisons. For hydrogen cars, you can obtain clean hydrogen. So hydrogen from electrolysis, from wind turbines, that's the imagined perfect world. Or you can do brown hydrogen, which is the #1 way of making hydrogen, which starts with methane. So happily, you start with a hydrocarbon. And because you start with a hydrocarbon, there's a very direct, almost one-to-one, really close to one-to-one relationship between the carbon efficiency and the miles per gallon fuel efficiency. So if you start with a hydrocarbon as a start place in order to make your hydrogen, then you end up with a CO2 equivalence of 240 miles per gallon, as well as a energy equivalent of 240 miles per gallon.
I think there's a couple more in the chat.
Yeah. Yeah, Austin, you're asking my research question, right? If we can put information in front of people that they can be more profitable, why don't they do things automatically? And, you know, people think they're exceptional. They say, yeah, I know that works in Toyota, and I know that works in all of these other places, but it won't work for us. I mean, this is a really interesting thing to study. And I think we've got answers to the question about how we get people who are disbelievers to begin to experiment, and we can see it happening at scale. We can see hundreds of companies using our tools and techniques at the moment, but still it's far too small. And I would like to encourage us to use very different techniques. For example, I don't believe in carbon pricing. Until we make carbon $200 a ton, I don't think we will generate the sorts of behaviors that we want. And personally, I don't think there's any government in the world brave enough to make it $200 a ton. So we have to find another answer. Let me give you a really easy answer, Austin. Let's hope that you own your own factory in the near future. If you take some of these tools on and make these improvements, I would want the government to give you an MBE, right? I'm assuming you're British and you're allowed to have an honor from the Queen. Why don't we just give you an MBE, make other people jealous, and then they'll copy you? That's part of my strategy, and I spent quite a lot of time trying to persuade ministers to do this. So please copy, and please get a gong, as they call it.
Interesting way of motivation. I think one more in the chat from Carmen.
How long will it take for industries to transition? Oh, so part of me worries that at the current rate it'll take forever, right? And you are going to have to live with the consequences. I'm looking at the age and guessing the age of the people in the room right now. You're the ones that are living with the consequences. I think the transformation accelerates. So let me get the data right. In 1905, 2.5% of cars in the USA, 2.5% of carriages were horseless. 97.5% of them were horses. 20 years later, that had flipped. So in 2 decades, we went from having hardly any petrol-driven cars to having hardly any horses. And things do flip very, very quickly. I believe that this decade and the next decade, we will see a large part of that flip in the industrial system. In some ways, I'm worried because coronavirus has now created a shock, and we're all going to be worried about that, and we're going to be dealing with a global recession. That'll be one of the outcomes of coronavirus. Not as terrible as the human cost, of course. But I wonder whether that will generate hesitation on the transition to sustainability, or will it generate acceleration? And I think there's some interesting evidence that it will actually accelerate. So I'm hoping that everyone in the room is going to live through this really interesting period. I think you're going to live through a period where organizations are going to be doing more experimenting, and the scientific method and mind is going to come to the front, as opposed to the pure economics maybe and political education that seems to be important.
I do hope so. I think Mario asking about says he was shocked at the Audi example. Yeah.
Well, Mario, if you named a sector, then I'd tell you the bad incentives in that sector. But you're right to pose the question, because there are so many perverse incentives. And so, for example, the European Emissions Trading Scheme, which charges company for emitting carbon. And cement companies are one of the greatest emitters in Europe. But because they take other people's waste, they burn tires. Traditionally, they burnt other people's tires, very carbon energy intensive. So really good way of getting to energy, and actually quite low carbon for the energy content. But they get bigger credits for taking low quality waste. So local authorities want to sell them their household waste, which is full of water and food, and is harder to burn and to generate a temperature that will convert limestone into cement, right? But because local authorities want to get rid of this waste, they are paying the cement companies more money. So the cement companies are taking that money, and that means that we are emitting more CO2 because it takes more of that type of waste to make 1 ton of cement than it would take if you were burning car tires. So it's an example of a really, really perverse incentive mechanism, and the world is rife with them. Xie-Wing Liu, you have answered your own question. You're right. And it's not just the direct cost or complexity of transition. It's not the cost of transition. You're right to point to the complexity. If something is complex, we are going to fear that transition. Actually, industry has the money to deal with the costs of transition. But what if that transition failed? So the fear of the complexity is a much bigger factor than the cost element.
Any more questions from the audience?
I think there's a very big point Lebergang makes. And I think, again, you're offering in part the answer that you have to bring people with different disciplinary knowledge together. And a large part of our systems thinking research is exactly about how you do that. And there are norms, rules of thumb that work when you're getting, for example, politicians who typically, if they have any training, are economics, plus industrialists, finance, science. When you get them in the room together to share information, there are rules about how to do that effectively and how to do it less effectively. And that's part of what we study. But it is very frustrating that we have enough science, enough technology, enough knowledge to solve this problem today. And would somehow generated the change at the speed that the world needed it. Peter, are you trying to wave and offer a question?
The other thing that came up in my mind is, where do externalities come into this thing? Because that's basically extracting value out of nothing, right? So that's still a problem in everything that you've mentioned. If you can pollute without any cost, that's an incentive for you to not do that. And the second thing, I come from my experience seeing some sort of industry-related conferences, is the industry, especially coming from a climate background, the industry sort of long-term plan is 5 years. Is this feasible without any of these big jumps? Can you do it like incremental changes, or does this the problem of to think far into the future also play a role in this thing? What's your opinion? Yes. Thanks.
Well, you like easy questions, don't you? So I can only offer simplistic answers. Any of these are worthy of a full debate. One of the interesting things about the efficiency argument is that they're not externalities. People pay for their energy, so why aren't they minimizing their energy? And it is interesting, if they're not even efficient with internalities, why are we shocked when they fail to be efficient with externalities? So first, let's learn how to be efficient with internalities, because that gives us some of the skills to deal with externalities. The second part of my presentation was on value innovation. And one of the reasons we do that is that we study and work with organizations that are deliberately internalizing externalities. So they're allowing their competition to keep externalities external in the belief that that's going to give them a competitive advantage. And the companies that we work with are deliberately internalizing. So if you take Riversimple, Riversimple is internalizing the externality of fuel efficiency. Most car companies, the fact that you pay the fuel bill is an externality. Riversimple said, no, we'll pay the fuel bill. But they found a way to turn that into 10 times more profit. So we are seeing a pioneering edge of companies who are deliberately internalizing externalities. If we go back to the conversation about politics, what we've seen in the recent past is very crude attempts to internalize externalities from politicians, because they're the people that are allowed to, right? As Adam Smith would say, you know, our job is to deal with the internalities, and it is up to government. You know, if you don't want mercury in the river, governments just make it illegal. You take the externality and make it internal. And governments have become scared of that. And not only scared, they become incompetent. So they do it in crude ways, which often generates unintended consequences. And we've already talked about a couple of those examples. So this conversation could go on forever. Time period, yes, you're right. But interestingly, even technology changes which work within that time period. Let's say I can install energy efficiency and I can pay for it in 2 years, often don't get prioritized, because what they're doing is they're competing for capital. It isn't that they can't generate return on investment quickly. It's that they're competing with a marketing budget. So if a marketing director comes along and says, give me $1 million and I'll have an advertising campaign that will sell more cups, and somebody says, give me $1 million and I will save $1 million of energy within 1 year, guess what? It goes to the marketing person, because it's less complex. Remember about complexity? We don't like complexity. Just give them $1 million marketing budget, sell more cups. So even things that act quickly are often not implemented. But I do understand your point. Short-termism is one of the biggest problems here. And I'm going to point to one last version of this. If you're the CEO of the company that I'm pitching to when I was explaining the fast fusion solution, remember I said you can make 3 times more profit, right? But actually, you're only going to get about half the amount of money from customers. So I'm going to make you much more profitable, but I'm going to make your turnover smaller. How many chief executives want to be a chief executive of a smaller company? Right? Ego is right in the middle of this. I would rather be less profitable, but bigger. You'd be surprised how often we come across this.
And I think a final one from Carmen in the chat about conscious consumerism.
Carmen, I'm not going to be caught in your binary trap, A or B. It's going to be both. Some companies are listening very carefully to their consumers and coming to the conclusion that they have to go through some sort of transition, and they're experimenting. Some companies are listening to that and going, I'm not sure about that signal. I'm going to wait a little bit longer before the signal gets stronger. And there's a third set which listen to the signal and say, but I don't want to be a pioneer. What I'll do is just enough action. You know, I'll run a little program here. I'll put a wind turbine up here. and I'll put it into my CSR report, and I'll talk about being green. And that's what we call greenwashing. So it's one of three responses. What we hope is that the people who are greenwashing are readying themselves to actually transition rather than readying themselves to go back into stasis and not change. But I think the number accelerating towards transition is going up. Unfortunately, even if it's exponential, doubling 0.001% doesn't make a big difference to the world for quite a few years yet. And that's the problem that we have. The ones who are making the transition are not yet 10% of the whole. Because if they were, you'd have so many examples around you that you would learn from them. It's still 0.0 something percent.
Okay, well, thank you very much for the really insightful answers to some not easy questions. And thanks also for spending this evening with us and sharing your thoughts and kind of illustrating to us that it's not that hard in a way.
Well, but the point is, it's not hard, and it is really hard at the same time. And I want to send some hope. I think that what I'm observing in business is much more enthusiasm for what I call experiments, where the scientific mind and rigor really play a healthy part in trying out new things, but in a way that's rigorous so that we can learn from them, rather than having the CEO's pet project, which was always going to go well. So there's hope. We need your brains. Please get out there and solve it. And then I can retire.
Yeah, well, good thing, let's hope. So yeah, thanks once again for spending your evening with us, and thank you for everyone who's still here for also spending your evening with us.
Thank you.
Yes, and so there will be the kind of members quiz, which Steve mentioned in his talk. We'll send it out, and a recording for this will also be made available on Thursday or later. So thank you once again, both Professor and audience, and have a good evening and rest of the week.
Thank you. Take care.